Hello everybody, in the name of Almighty Allah, welcome back to the next video from Google Earth Engine Explorer. Today we're going to calculate some indices and the ways how to import data into the Google Earth Engine Explorer and how to export, calculate it, or process the image from this environment to your laptop. All these will be discussed in this video, and I wish you to enjoy this tutorial. So, in the previous video, we discussed about how to activate your account and how to get into the Google Earth Explorer. So today we are going to start directly from our one workspace. So you may created your one workspace. So for specifying your study area, just it would be enough to zoom at your study area label. So for example, I'm going to process the image related or concern or belongs to this area. So now I zoom to this area because we have various classes in this location, as you see. And here at the center of this vegetation covered area, we have a city, and around this city are surrounded by vegetation covered area of the gardens and also mountains and other classes. We have two or three ways to import the data into the your workspace or add layer at this present extent. So you can add the data by data catalog, and you can select any of them that you want. So daily data, 8D data, or 32D data. So or surface reflectance. TOA reflectance, radiance, surface reflectance, or line surface temperature, SRTM, or any other of this data according to your necessity and according to your objective, you can add. So now I click on the TOA. So I wait the list of the data to be loaded here. So you can see here various type of atmospheric corrected data. These data are collection level 1. It means it's radiometrically corrected, but you must correct or apply atmospheric correction on this type of data. Still, this data has the influences of atmosphere. And when you load the list of data, be careful to see when you see a data, just consider is there the option open in your workspace or not. If the option open in your workspace exists, it means the data is available for you. Otherwise, it will be available as soon as possible. And here you can see Lancet 8, Lancet 7, and Lancet 4TM, Lancet Team Series, and Lancet OLI or Lancet 8 data available here. So now I select here, open in workspace this data, so it will be added in my workspace. So let's see here, and also you can click on the add data to activate the search box here, or you can directly click here the search box to add the data too. So you can search here. For example, you can click on the Lancet theory of percentile composite or any of this data, or you can search just by typing the exact name of the data to add in your workspace. But I prefer to add data via data catalog. And let me to explain this. So daily data means the data uh, that's related to a single day or the data of a single day. When you load the daily data, if you want to load Lancet data, you will acquire or you will access the daily data of the Lancet. But when you load HD data, any any of the data that you access is a composite of the HD data entered to this also. And when you load top of atmospheric data, so here you can find different choices, and you can select any of these. Maybe it is a single data, maybe it's 8 or 2 data, or maybe it's an annual data. So I add this Lancet collection level 1 TIR 1 annual TOR reflectance. So I add this data in my workspace and I wait for a while to be this data to be added. And here, so you can load data in a single grayscale band or a composite of false colors of three bands RGB, or and you can specify the date here too. So this is annual data. This is the composite of all the images that have been taken by Lancet 8 in 2021. So if you want to have the data earlier than 2021, so you can select here. For example, I select here, it's the data related to 2020 here. So, or you can load the data of the 2019. And you can apply this. And you can check out this the quality of the image. So if it is acceptable for you, it will be okay. Okay, otherwise you can change your data. So as I see here, some gaps are in some borders of the images during the mosaic left an effect here, and definitely it will affect our image processing. So I'm gonna change this data and load another data here from here. Better image to be processed. So let me select line set 4, line set 5, 7, 4. The real-time reflectance, HD reflectance, and the 32D. Let me load the 32Ds. You can turn on and off the layers from here. So now it's okay here. September 14, 2021 up to October 16, 2021. All the images taken in this data interval are composed to create this image. Now I have this one. So now I can apply and save. Now I'm gonna delete this one. So here you can change the color composite of the image. So for example, B5, B4, and B3 to create a false color visualization. This one. So after importing your specified image here, and you can do your calculations. As I mentioned in the previous videos, here we have some calculations. For example, applying masks, thresholds, convolutions, derivative, LJD, slope aspects, expirations. And today we are going to apply some indices on this image, and we'll learn how to export the result of the uh, calculated index. So here, uh, today we are going to apply these indices, NDVI and uh, NDMI or NDWI, normalized difference mixture index or normalized difference water index, and MNDWI, modified normalized difference water index, or EVI. Definitely we will talk about this these two indices and other indices in the next video, or maybe in this video, but definitely we will calculate these indices and this index in this video. So let's try it. At computation, you can click on expiration here, and you must wait. The image or the window must be loaded. So in here, you must select your image. Now I have only one image here. So this is only one image in the list. If there is multiple layers, multiple image loaded in this panel, so you will see here multiple list of images. So now I select line city hashed, and this box you can specify your name. So the name of the image will be used in your calculation or in your expiration here. Then you must try to rename this box with an easier name. So for example, this is Lancet hashed and I will rename it by L. So here now I can uh, write here the formula of the NDVI. So in this the formula of the NDVI, you can see here NIR minus by R divided by NIR and plus R. This is the formula. In Lancet hashed or in Lancet 8, sorry, uh, bond 5 is NIR and bond 4 is the R or read. Read infrared or infrared read and read bonds. So in here, you must write the name of the bonds and so into the quotations. So you can see all the bonds here and you can check and uncheck name of the bonds to be loaded in this window or in your workspace to be visualized or to be part of color composition or not. So this is quotation. Now I use B5 minus by B4. I must use the quotation tool here and you must specify your bonds to the in your calculation in which image these bonds are consist of. So here we have the only image that L. Now I say bond 5 of L here. Bond 5 of L. Now I create a copy and paste here. And now I change minus to the plus. So in here you can see bond 5 minus by bond 4 divided by bond 5 plus bond 4. So now here bond 5 minus by bond 4, so divided by L bond 5 plus bond 4. Now I can save it. So now it's saved. It will be applied here. Now this is the result. Once you calculate your index, so here you can see, and let me turn off this one, and this area with the brightness color or white areas are the area of the vegetation or vegetation covered area. And what's the goodness of this? If you calculate an NDVI In an application like NVI or QGIS or ArcMap, you can uh, calculate only unlimited image, and you need more network to you have to uh, spend more network to download the image than you have to mosaic them. After that, uh, you have to calculate that. So in here, you can calculate the vegetation of uh, a large area and download the result only in few MBs or few KBs. So it's most easier. Once you calculated your image, you can apply your thresholds. You can specify your classes. So uh, in here, uh, you can click on threshold here. I will wait here. Now I will specify my image on which that I want to apply a threshold. So I click my NDVI. You can edit its name here, all your processing image, NDVI threshold. NDVI threshold, and I click here. So now it's selected. And first, I want to see the visualization. Now, the range of values are from 0 to 1. So from here, add threshold. For example, from 0 to 0.2 is considered as a class from 0.2 to 0.3 another class, and from 0.3 to 0.5 another class, and from 0.1 is considered another class. So 1, 2, 3, and 4. Now I can save it. Now I'm going to load this, and in visualization, instead of the gamma, I select the palette. For example, this is one color, and the next color, and the next color for the next, and for the next. This is my color composite. So now I see an inappropriate image here. So definitely the problem is in my classification. So in this case, we definitely need to change uh, intervals with the values of classes or the number of the our classes here. Uh, I'm going to delete one of these. Let's see what happens. Now I have only two classes here. So now you can see it's a little bit better, but it will be uh, great to apply your reclassification within the applications on your computer. So now I'm going to download part of the calculated NDVI or in any location that I want. So in here, once you load the image, you can see here uh, the download option. You can click here. You have to wait for a while, and this option be loaded here. From this location, I'm going to download this area. So in this button, you can find the options to specify the downloadable area or the area that you are intended to download. So here's three options. Viewport will download all your screen or the area that's visible allowed it in your screen. And the next one is you will draw a rectangle, and the third one is a polygon. For example, you specify by clicking the locations like this. Now I'm going to download this area. So you can see here it's preparing to be downloaded. And let's check download folder. So this is contained in a zip folder. So I can add this data into the ArcGIS. So this is our downloaded data in the NDVI that we are calculated here. You can see the values of the NDVI here from minus 0.003 up to 0.266. From approximately dark soils to dense vegetation covered area. So in here, you can do a little bit investigation about the values of NDVI to get some knowledge and be familiar with these values and which values must be dedicated for what class. So here you can see what are considered as minus values under 0.046, and clouds are considered very low positive values, and dry and bare soil are considered as uh, allow positive values, and this value considered as a dense vegetation coverage area. So definitely these values are not a single value, these are a range of value. For example, from -1 up to minus uh, 257, it can be considered in the range of water, and from 0.025 and upper values can be considered vegetation coverage area or dark soils. Uh, okay, now I'm going to turn off this and remove this one. I want to calculate the next value. So let's see now here we have NDMI, normalized different moisture index, or NDWI, normalized different water index, can be calculated like this. Bond 5, a normalized ratio of bond 5 and bond 6. So you can copy this and open a new expiration. So in here, I will paste this. Only I change band 4 with band 6 here and save this. What it says. Okay. Now I wait the image to be loaded. I'm going to find some location that has water bodies to assess the so this is a lake on the mountains of Badakhshan in North Afghanistan. So we're going to see how this index works. And it takes a while to be loaded. Oh, sorry, I didn't select the image here. So I have to select the image and rename this. So, and I'm going to rename this one, NDWI. So you can see all locations where the water bodies on this map are highlighted or has the highest value like this. and the location has more moistures. Definitely, these locations are the mountains or the hills that has more moistures. And these are the rivers that highlighted well. And the vegetation coverage area definitely has enough moisture that shows a higher value rather than surrounding areas. This. And if you want to download or export the image related to your uh, objective area or your study area, and you can select the location by drawing polygon, and you can specify to be downloaded. I think it would be great to mention something about the filters here after calculating these indices. So most of the time we use the filters after applying a classification or uh, calculating an index. So we have generally two type of filters. One is low pass filters and the other is high pass filtering. So uh, according to our objective, we will use these filters. Let me choose a location without a gap. So here we see the gaps between the Landsat images and these areas does not covered by the satellite image. So it means all the areas does not covered by the Landsat image uh, at the same date. So in here, you can apply filters. We have here derivative filters or morphology or convolution here. Mostly the convolution filters are considered as low pass filterings. Uh, Low pass means our application is to smooth the edges. When you see the border of the uh, 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 phenomena here, if you most of the time it's necessary to be sharper here, and most of the time you need to smooth this border or this edge. So, and your objective here will decide or force you decide which type of your which type of filters will you apply in this area. For example, uh, min and max are these are high pass filtering. So when you apply mode or mean, median, so mean and median are considered as uh, low pass filtering, and mean also considered as a low pass filtering. And when you select max, it considered as a high pass filtering. So, and you can select the kernel size or the kernel type. What would it would be? So circle, square, or cross, or plus. And now I'm going to, for example, apply a mean filter on this NDWI. And radius of the pixels, how many pixels will be the radius, and the iteration also. So I select 5 pixels and the iteration size 1. So now I save this. Now you can see now the edges or the borders are now smoother than original MNDWI here. So MNDWI is used mainly to calculate or to extract water bodies, but it depends on the moisture of your study area. If it's a wet area and water body can be found in composite of the soil, so any area with a high moisture will be uh, specified by higher values, and the locations or the areas by lower values will be or uh, low moisture or low water in soil composition will be specified by lower values. So thanks for your attention for the video, and I wish you to enjoy these tutorials and the next videos from Google Earth Explorer will come uh, back to this video. Thank you.